All right, let's talk about something you've probably seen in the news and thought, huh, we're going to tackle a puzzle. How can one single event, like an earthquake, be described by so many different and honestly kind of confusing numbers? Let's dive in. So you see that headline, right? A 7.0 magnitude earthquake hits. It sounds big, it sounds super specific, but what is that number really telling us about what actually happened on the ground? Well, the answer might not be what you think. And this is where it gets kind of weird. This is the heart of the puzzle. You can have two earthquakes, both officially a 7.0 on the scale, but with totally different outcomes. I mean, one barely rattles the windows, and the other just flattens an entire city. And no, that's not a typo in the news. It's because we're looking at the same event in two completely different ways. So how is that possible? Same magnitude, totally different story. To get to the bottom of this, we need to wrap our heads around two separate ideas: the raw power of an earthquake and its real-world impact. And here's the key: they are not the same thing. Okay, first, let's start with the human story. Let's put aside all the scientific instruments for a second and just think about what it actually felt like to be there. This is all about the shaking, the immediate effects you can see and feel. Now, the fancy term for this human story is intensity. Notice, this is not a measure of the energy way down at the earthquake source. Nope. It's a measure of the effects that we can observe on people, on buildings, on the whole environment in one specific place. And the way we measure this is with something called the Mercalli scale. This is really cool because it's not about machine readouts. It's based entirely on what people saw and felt. It's a journey, right? It goes from a Roman numeral I, where you don't even feel it, up to a V, where, stuff starts breaking, all the way to a VEI, where buildings start to collapse, and then a 12, which is just total devastating destruction. So the big takeaway here, the Mercalli scale gives us that boots-on-the-ground view, what actually happened in a specific city. But it has a weakness. It's subjective. I mean, think about it. A city full of modern earthquake-proof skyscrapers will report a way lower intensity than a town with poorly built structures, even if the ground shook with the exact same force underneath both. Right, so that's the human side of the story. Now, let's flip over to the pure science and see how we get that single objective number you always see in the headlines. This is all about measuring the raw, unfiltered energy. And that one number? That's what we call magnitude. Now, unlike intensity, which can be different from town to town, an earthquake has only one magnitude. It's a single measurement of the total energy that was unleashed right at the source, or the focus, deep down in the earth. We measure this using the moment magnitude scale, or MMS. And this is where things get really, really mind-bending. The scale is logarithmic. So what on earth does that actually mean for the power of an earthquake? Okay, let's say we have a magnitude 6.0 earthquake, right? Sounds pretty significant. And you'd probably think that it's just a little bit weaker than, say, a magnitude 7.0. I mean, it's just one number difference, isn't it? Well, with a logarithmic scale, nope, it's not like that at all. Not even close. Okay, get ready for this, because this is the logarithmic leap, and it is huge. Every whole number you go up on the scale, so from a 6 to a 7, the shaking, or the wave amplitude, gets 10 times stronger. But look at the energy. That 7.0 earthquake isn't just a bit stronger. It released about 32 times more energy than the 6.0. That is a massive, massive difference. And this whole idea of a logarithmic scale measuring raw power, it's not just for earthquakes. Scientists use the exact same principle for another one of nature's most powerful events, volcanoes. For volcanoes, they use something called the Volcanic Explosivity Index, or VEI. And you guessed it, it's logarithmic too. It measures how big an eruption is based on things like how much ash gets blasted out and how high that eruption cloud goes. So just like with earthquakes, a VEI 5 is just astronomically more powerful than a VEI 4. Okay, so we've got intensity, what it felt like. We've got magnitude, how much raw power there was. We even have a scale for volcanoes. Let's pull all these threads together now and see how they give us the full picture of a major geologic event. This chart lays it all out beautifully. You've got the Mercalli scale, which is all about intensity, the felt effects, based on what people saw. Then you've got the magnitude scale, measuring the raw energy released, based on hard data from seismometers. And for volcanoes, the VEI measures the sheer size of the eruption.
See? They don't compete with each other. They're all just different, complementary pieces of the same puzzle.
So here's the bottom line. It's actually super simple when you break it down. Intensity tells us the impact. Magnitude tells us the power. One is the cause, the other is the effect. And you absolutely cannot understand the full story without both pieces. And this is why it all matters so much. This isn't just academic. By combining magnitude and intensity, scientists can figure out the physics of our planet while also analyzing the real-world effects on people and cities. It's an absolutely essential combination for figuring out hazards and managing risk. Which really leaves us with a final, big question, doesn't it? We have these incredible tools to measure and understand the immense power of our planet. The real challenge is, how do we best use that knowledge to prepare, to engineer our cities, and to build a genuinely safer future?